Okay, so the first questions here, you would not have a calculator for this whole page. This whole front page would be, I would expect you to do it without a calculator, okay? Okay, so the square root of, so treat the coefficient first. So the square root of 100 is 10. And then how do you square root an x to the 6th? X cubed, yep. Yep. Okay, so when we square root this next one, I need you to think about the square root of 49. 7. How many zeros are there in here? 6. So ours would have 3. 7,000. Okay. The next one, same idea. What's the square root of 81? 9. How many zeros? There's 4 zeros, so you're going to need 2. And it's a decimal, so you make sure you put your decimal in the right spot. Okay, the square root of 81 over 16. So you just need to square root each separately and treat it as a fraction still. So the top is the square root of 81. 9. Square root of 16 is the bottom. And the last one, I'm going to give you a second to think about what you want to put here. And what are we thinking about this one? The square root of a negative 25.
Not possible.
It's not possible. You cannot square root a negative number, right? Doesn't matter. Like that one? Just half of the zeros again. Okay, make sure you have all your rules down pat. Okay, the deal is with the coefficients, you just do the math that you see. And the exponents, you do the rules, right? So the math here is timesing, so no calculator. 8 times 7. 56. Then we do the exponent stuff, so x to the, and then you know the rules. When you're timesing, you do what to the exponents? Add. Okay, no calculator, right? Okay, this one should take you 2 seconds if you know the rule. 1. Anything, I don't care if I put crazy looking stuff to the 0, it's 1. Okay, do you understand here that 7 is the base? It's not the coefficient. So it's now into the rules. So it's 7 to the what? And 8, subtract. And I wouldn't expect you to evaluate that as a number, okay? Because on this, you wouldn't have your calculator, so I wouldn't expect that for you. Okay, so this one, the coefficient, do the math. So what is 8 squared? So 64. The exponent, you do the rules. What's the rule with exponent to exponent? Multiply. Okay, I often get this as an answer. I often get this as an answer because what did this person forget to do? They forgot to do the math on the coefficient, and that happens quite often on that one. Okay. Do the math on the coefficients. So it's a 28 divided by 4 in the math. 7. Do the rules with the base exponent stuff. X to the 6. Subtract. Okay. Do the rules, or do the math with the coefficient. This math would be a 5 cubed without a calculator. 125. Base exponent rules to the 21. Okay. Again, this 4 is the base exponent stuff, so it's already in the rules. It's not a coefficient. So know the difference between when a number is a coefficient or a base. This is just a base. So straight into the rules, the base 4 to the what exponent with the rule? 15. So multiplying, you add. Okay, the coefficients, there's 9 and 8, multiply, so just the math, multiply them. X to the, did you pick 4? Because there's secretly a what on top of that? A 1. Okay, and the last one is just the rule, what's anything to the 1? Just itself. Yeah, just leave it as itself then. Okay, so this instruction is to evaluate. So the word evaluate means I need a number as an answer. Give me a number value. So 8 to a 0, we know the rule with 0. 1. The exponent 1 is itself, right? Can you finish this third one here on your own then? Because I just did those two. So a 0 degree is a 1, and this 1 is itself. So that answer should be 12. Okay, this one says evaluate, so I need to come up with a number. And I don't have a calculator on this section. We're doing this without a calculator. The base 5 to the rules. Go to the rules. Subtract, so 3. Can you do this without your calculator? 125. Okay. The next one involves some negative numbers. So what do you think? Plus or minus 64, which one is it? There's your multiple choice. Minus 64, because it's like me saying, what is the negative of 8 squared? Whoa, sorry. The negative of 8 squared. Okay, what about this one? Positive or negative? 81. Positive, because this one says different. It says what is negative 9 squared. There's one rule that I didn't put on here, if I can just put it on the bottom somewhere. What is negative 1 to the power of 58? Positive 1. What makes you know if it's positive or negative?
If it's even or odd.
If this is even, so negative 1 to the 67 would be odd. Okay, so that may be another rule that I just realized I didn't put on there. Okay. You should have your definitions of what numbers are memorized. Okay, so we start with natural numbers. Natural numbers is where we would start. What are natural numbers? 1, 2, 3, 4, etc., etc. Then, whole numbers are all the natural numbers with the addition of 0. Then we have integers, which are all the naturals and the whole numbers with the addition of negatives. So now I've also included -1, -2, -3, etc., etc. Then we have rational. And now what are we adding into the mix? Fractions, decimals that either stop or what else could they do? Repeat, yeah. And then we have irrational, which is things that don't repeat, don't stop. Okay, so where would we place 3/7? Did you put it under the rational category? The square root of 50, would that be a square root you can do or not do? You can't do that nicely. It'll be a long decimal, so then it would be outside here, irrational. It would keep going. I'm trying to think if I put this on a not calculator section. Probably. The square root of 50? You just basically need to know, is it one of the perfect ones or not? No. Yep. Square root of 64 with a negative in front of it. Can you square root 64 nicely? Yes, 8. But now there's a negative in front of it, so really this is the number -8. I secretly put a -8 in there in a different looking way. So where would you put -8? It's an integer. Then a +8. That's a natural. -10. Integers. A decimal that I don't see it repeating, and then it says it just keeps going on forever. So this would be irrational. So I'm just going to go 0.52 ... to show you that that's that one. 0. Whole number. I always remember that one because whole, the word has the letter O in it. 13 is natural. 0.42 is a decimal and it stops. So that's rational. 0.151515. That's also rational because it repeats. Okay? So you'll have, I don't think I put it like this on the test. I think I just make you write. What is it? So it's not in a circle. So you just have to write down, this is a rational. This is a, okay, and estimating, this is no calculator allowed. So you really have to have your squares memorized. When I say no calculator, you will have your one piece of paper with you that you did, where you have all your squares. So you'll have that paper, okay? What square root is lower than 70? Square root is 64. And then the next one above 70 would be the square root of 81. So my number is going to be between an 8 and a 9. So I need a 1 decimal guess. So you should be 8 point, and then you have to take a prediction. I would say, is 70 closer to 64 or 81? What do you want to do here? 8 point. It's closer to 64. 8.5? I wouldn't. I don't think I would go 5. 8.3, 8.4, 8.2. I would accept basically anything like that because it's an estimate. Okay? I think all 3 of those would be pretty reasonable. Okay, the square root of 0.5. What's the square root lower than doing that? Square root of 0. What's the square above that? Square root of 1. So I'm somewhere between 0 and 1. Anybody want to take a guess? 0.7? Yeah. Did you know that when you square root numbers that are less than 1, you actually get bigger? You want me to give you an example? What's the square root of 1/4? So what's the square root of 1? What's the square root of 4? Look at that, it got bigger. So when you square root numbers that are less than 1, it gets bigger. Oh no, I didn't do this example. I did a separate thing. I did one where I knew the square root of 4. I didn't do this example. I did just a different example. I did the square root of 0.25 just to show you that it got bigger. Yeah.
See, we had that question on the test. What would be the range that you would accept?
Just 0.6, 0.7, 0.8. Yeah. But it would get bigger. Yeah. Okay, the square root of 83. Are we agreeing the square root of 81 would be below it? And the square root of 100 then would be the next. So this needs to be between a 9 and a 10. So 9 point, what do you think? 9.1? Yeah, that's a good guess. Okay, because 83 is just slightly bigger than that, yeah. Okay, pay attention, this is a cubed root. So do you know your cubed root numbers? Give me a few of the cubed root numbers in your head. Cubed root numbers, 8, 27. Okay, so we know the cubed root of 8. And the next cubed is 27. So therefore, this is going to have to be between 2 and 3. So it's going to be 2.6, 2.7. Okay, kind of in that ballpark for a guess. Yep. Okay, the cubed root of 120. What do you know about some other cubed roots here? You probably are thinking a cube root of 125, right? but you're not quite there. What'd you say there? 64 is the one. Okay, and you would have your chart, I think, at this point, right? Your cubes. Because I will have you make your cubes up to 5 or 6. So you'll have this chart. So we're between a 4 and a 5. So 4 point. You said 4.9 is what you want to do? 4.8, 4.9, acceptable like that. Because 120 is pretty close to 125. Okay, negative exponent rules. So, no calculator on this question. Still no calculator. Lots of stuff you can do. What's the rule? Negative exponents. Move it. So this would go to the bottom as a 9 squared. And then I would expect you to go more 1 over 81. Okay, if you don't simplify it, you would get some points taken off there.
But it doesn't say simplify.
There was actually no instructions at all. Look at that. On your test, I would say something like simplify out. Or that one would be evaluate. Evaluate, simplify, both of them, yeah. So I'm going to move this to the bottom, and this also is going to move. So they're both going to move. So 10 squared is now on the top, 4 squared is now on the bottom. So I get 100 divided by 16. And that's as much as I expect you to do that. Don't try to simplify it. Don't try to decimal it. That's it. That's all I want, okay? So this negative exponent is on the bottom, so I'm going to move it to the top. So 8 squared. Okay, this next one, there's 3 things. You got to ask yourself, do I keep it or do I move it? So the 3, would you leave it there or move it?
Keep it.
Keep it there. 2 to the negative 2, should it stay there or move? Move. 5 to a negative 2, should it stay there or move? Move. Okay, so in this, I'm going to put a bunch of things in some of the questions where you're really going to have to concentrate. Keep or move, keep or move. So 3 times 25 divided by 4. Trying to give you numbers you can still do without your calculator. I would expect a 3 times 25 you can do. Okay, the next one, the last one here. 10 to the negative 2, should I leave it there or move it? Move. 5 squared, should I move or leave? Keep it. Just leave it on the bottom. I know now it's your instinct to move things, but that one wouldn't move. So 100 times a 25, can you do that without a calculator again?
2,500.
So 25 and then 2 zeros on the end of it, right? Okay, all that I'm still expecting no calculator stuff. Okay. So now same rules, but then the math just has some fractions in it, okay? So we're going to add exponents. So 3/4 plus 1/5. Adding them. Okay, doing this work without a calculator again. What do you want to make as a bottom on this? 20. So I'm going to have to times this one by 5 and this one by 4.
If we didn't put the x there, we get to off
Because that's the base. So you make sure that's your base is there. Is that what you mean?
Yeah.
Yeah. And I get that a lot. People are working too fast and then they just forget to just write your base in there. Yeah. Okay, the next one, I'm just going to write the math with the coefficient. So the coefficient is 24 x to the 24x to the, and this is again just an add one because they're getting multiplied. So add Are you picking 12? Okay, let you do your work. Pick 12, work it through, and we'll check our answers. Okay, the next one is x to the what? And then we're going to have to subtract exponents. Okay, you're going to have to use a 6 on the bottom. So this would get times by a 2 and by a 3. Okay, the last one, math on the coefficients is 90 divided by 10. 9 x to the rules, subtract exponents. What do you want to pick with a 4 and a 6? What's the lowest one you can pick? 12. You can pick a 12 on that one. So I'm going to times this one by a 3 then, and this one by a 2. To make this a 12 on the bottom, to make this a 12 on the bottom, what are you doing? Times e by 3, times e by 2. Okay, and then these ones might be of the more challenging type on the bottom. Okay, that's good. Okay, what is the math on the coefficient? So remember, math on the coefficient, rules on the exponents. What's the math on this coefficient? 36 to the 1/2 means what in math? Square root. Okay, so that is going to be a 6. The math on that is a 6. And then what do you do with the exponents? The rules. So then we're going to do 8 times 1/2. And then without a calculator, what's 1/2 of 8? 4. Okay, number 2. The math is what's 125 to a 1/3? Well, what is that the same math as you would do? Cubed root. So that number should now be 5. And then the rules, you're going to have to do a 7 times a 1/3. And then how would you just write that then?
7/3.
Just 7/3. Okay, the next one, we're going to have to do inside the brackets first. So multiply this. So this is going to be 2 over 21 x to the, so the math on the fractions, 2 over 21 x to the rules, add 12, and then to the 1/4. Okay, what does doing something to the 1/4 really do as a number? 4th root. I don't expect you to know that, so we're going to just write it the 4th root of 2 over 21. X to the and then what exponent are you going to get? You're going to have to do a 12 times 1/4. What do you end up with there? 3, right? 1/4 of 12, or 12 divided by 4, however you want to think about that. Okay, last tricky looking one with a bunch of stuff going on. So we're going to, again, work in the brackets and then exponent. So I'm going to do this first. I'm going to add, so 1/2 plus 5/6 equals. So you have to add the exponents first because that's going to happen inside the brackets. So I'm picking 6. So I'm going to do a 3 on this one now, timesing it by 3. 3 plus 5 is 8/6. Some of you might reduce it. I'm okay if you don't. That's all good. Okay, so x to the 8/6 is now taken to the 2/7. So then the rules is to multiply. So you should get and before this test, if you feel like you need your multiplication table practice, you can let me know and I can just print you some blank multiplication table stuff. Okay, coefficients, the math. What is the cubed root of negative 216? It is a magic one. What cubes to 216? Anybody remember that one? 6. So this would actually be negative 6. Negative 6 times negative 6 times negative 6. And then the exponents would need to multiply. So negative 2/3. But what if I told you you couldn't write your final answer with a negative exponent? Can you make that look different? If you can't write your final answer with a negative exponent in it, what would you do to change the look of it? You're going to move it to the bottom, right? But what about the coefficient? Does it stay or go with it? It needs to stay. Because the coefficient doesn't have a negative exponent on it. The x has the negative exponent on it, but the negative 6 doesn't. Okay? So that one, making sure you understand. Okay, 90 to the 1/2, changing it to a radical would look like this. 90 to the 1/2. That's where you put the 1 and the 2, but in math, we don't show anything to a 1, and when we do a square root, we don't show the 2. Those are the ones that are the secret ones or whatever, right? Okay, so this, I guess I could have put that over there. 9 square root of 90. Okay, so this one, if I really wanted to change it, it would have a 40 with a 1, and then there's the 5. So there would really be a 1 on top of the 40, right? It's a secret. So the 5th root is a 40 to the 1/5. The next one will be a x to the what? I'll give you 2 choices. Is it the 4/7 or 7/4? 7/4. Okay, this one is the radical with a 9. Where do you put the 3? Where do you put the 4? You can't on those ones. Can't simplify it anymore. 3 and the 4. Okay. The next one has a magic number in it that's not showing. There's really 2. So when I rewrite it, it's an 8 over 2. Which could technically be written as an x to the 4th. Okay, so there's a radical x. Where do you put the 5? Where do you put the 7? So you need to be doing the 7th root. Okay, and the next one, what is common? There's a 1/2 and a 5/2, so I'm taking the what root? Taking the square root of an x1 and a y5. So here you can see my 1/2, and here you can see my 5/2, right? But I would like you to not write it like that.
What if it was 5 over 3? Like y 5 over 3?
But and this one was still a 2 on the bottom?
Yeah.
Then you can't write it together because it's not the same radical at that point, right? Because you're saying this one would have had a square root and this one would have had a cube root. No, you can't mix and match that. So if I rewrite this, I'm just doing an x with nothing on it and a y5. And I'm not doing the 2 because it's implied. Okay, so this one would look like this: 10x6 to the 1/2. The unit 10x6 to a 1/2. Okay, so then vice versa, if I start like that, this would be 4x12 brackets to the 1/2. Ooh, you could simplify that. What's the number in the front now if you wanted to change it? Here's a 4 under a square root. So the number is 2x to the new exponent, 6. I did the math on the number, so the square root of 4, just math, 2. And then I did the rules with the exponent 12.5 times it.
But then you wouldn't add the 1/2. Because it's square root of.
I did the half when I did 12 times a half. Yep. Or 4 to a 1/2, which is the square root of 2. Okay, this one, what's the root? You're taking the what root of it? 5th root of an a to a 1 and a b to a 4. Okay, this section Okay, this section is evaluate, so we need to come up with a number here. So I first want you to take the radical part. So what is the cubed root of 27? Do you see how I'm doing that? The cubed root.
Why though?
Because again, up here, because like for instance here, if there's a 4 on the bottom, it's a 4th root of something. Whatever's on the bottom is the root. So 7 is on the bottom, so you're taking the 7th root of it. So I'm taking the 3rd root of it. So what is that without a calculator? 3. Then what is 3 to an exponent negative 2? What do you do there? Flip. Negative exponent, move, and then evaluate. Okay, next one. So I'm going to do the radical part. So what is the 5th root of 16? Do you know what times is itself? What times what times what times what times what? To get to 16, what do you have to do? 2? 2 times 2 times 2 times 2 times 2 would get you to 16. Now, what is 2 cubed? Oh, yeah. That's probably, yep. I'm just going to change the question. That's probably what I wanted in the question because I can't do it otherwise. Sorry, I bet you that was supposed to be a 4 or something on the bottom. Or I was going to change that number to 32, either or. Okay, redo the question. The 4th root of 16 is 2. 2 cubed equals, final answer, 8.
How, but we don't know how to do it.
You do for 2. Because you're going to have a paper in front of you where you have 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. You're going to have that paper in front of you at this time. Okay. Ready? What is the cubed root of 8? Cubed root of 8. So 2. Now what's 2 to the negative 4? What do you do with negatives? Move them. And then what is the 2 times the 2 times the 2 times the 2? 16. Okay, and this last one, so you're going to do the cubed root of 125. So you can do that without your calculator. The cubed root of that is 5. Then you do the 5 squared. So your final answer is 25. Okay, multiplying radicals, so root 8, root 4 makes a root 32. Just multiplying the numbers. So this one would be root 99. This one would be root 36. Wait a minute. That just is 6. Six times 6 is 36. Well, now the square root of 36 is just 6. this one, you have to make sure your whole numbers and your radicals don't get mixed. So the new whole number, there's a 6 here and a 7 here, so that's a 42. There's a root 6, root 5, so root 30. Whole numbers, radical numbers, don't mix and match. So whole number 9, radical 35. Okay, breaking down your roots, you got to have your magic numbers ready to go. So you'll have your paper at this point. What square root can I divide 32 by? Actually, you have your calculator now. I think I gave you your calculator now. 32 is divisible by which one? Which one of those good numbers that we need? Square root numbers. 16. 16 times 2 will make you a 32. So root 16 times a root 2 will make me root 32. What is the root of 16? 4 root 2. Okay, so yes, you have your calculator on this question. All right, working backwards. How did I get a whole number 4? What would have been in front of that? The square root of what? 16. So the 4 came from a square root of 16. So the whole square root would have been 80. Okay, the next, what makes 12? How do you make a 12? Which magic number? 4. So root 12, I'm now changing to a root 4, root 3 to make a root 12. Don't forget, you just have this 7, it's a long. The square root of 4 is the whole number 2, with no radical now, right? And root 3 Okay, now we're going to try one with cubes. So again, your cubes are 8, 27, 125, you have a 64. 24 is divisible by 8. 8 times 3 is 24. So I'm going to change 24. So I'm going to go the cube root of 8 times the cube root of 3, because there's my 8 times 3. The cube root of, just separating them. The cubed root of 8 is 2. Okay, how do you find a 4? You're going to have to be doing the cubed root of something to make that whole number 4. To pick 64, the cube root of 64 would give you that 4. Times the cube root of 5, just there. So together we're doing the cube root of 64 times the 5 underneath makes 320. Okay, I don't know. Let's see. We can finish this last one in the chart. 81. What cube can we divide out of 81? Cubed. 27 times 3. Okay? So cubes. So we always have to separate our brains with the square numbers and the cube numbers, right? So remember there's just a 2 here. So 81 is going to go into a cube root of 27 and a cube root of 3. Okay, so that's where I was getting my 81. So there's the 2. I just rewrote it. The cubed root of 27 is the whole number 3. The radical part is there. The whole number parts are separated from it, which is going to be 6 cube root of 3.